Alright, we're going to start with day 2, and so far we've seen exponential functions with rational bases, meaning 2 to the power of x, 3 to the power of x. They are all rational numbers, but right now we're going to see exponential functions can also have irrational bases. That means bases that are irrational numbers. Irrational numbers are like square root of 2, pi, but that's not what we're talking about. There is a very common irrational base that we see in a lot of the exponential logarithmic function called the e. It's called the natural base e. And you can go ahead and read this paragraph, but it basically says that this irrational number came about because of a financial formula of 1 plus n over 1 plus 1 over n to the power of n, where n is basically 1, 2, 3, 4, and so on and so forth, and n represents whether it's how many times in a year that it's growing, meaning that if n is 1, it's once a year, twice a year, and so on and so forth. So when we had substituted for n, it basically had these values. When you substituted n equals to 1, you had 2. And then this was when n equals to 2, and you substituted that, you got 2.25. And then when you substituted for n equals to 4 here, 1 plus 1/4 to the power of 4, you got 2.44. And then you will see that if you look at your notes that it is always getting closer to 2.718, 2.71828, and so on and so forth. So it's getting closer and closer to a particular number, which basically means that the natural base e as n is going towards infinity is 2.718, and so on and so forth. And this became a very common base for a exponential and a logarithmic function, as we will see, because this came about in the financial need. So to keep it short and simple for now, all you need to know is, just like you had 2 to the power of x and 3 to the power of x in exponential function, we will be looking at e to the power of x because of a certain financial function that was needed to be used. All right. So keep in mind, e is nothing but a number. Just like pi has a value of 3.14, e has a number of 2.71. So that's the value of e, or 2.72 if you want to, 718 if you want, or 2.72. So it's a number, it's not an alphabet. Just like pi is not a symbol, it has a value. E also has a value of 2.718 and dot dot dot. And it follows all the rules of the exponents. For example, I'll do a couple. For example, if I look at a, if e is the base, this is basically e to the power. What do you do? If the base is the same, you add the exponents. Similarly, let's do a few of these. So for example, this will follow the same. So this is in the exponents, and each of them is raised to the power of 2, which basically means this is 3 squared. This is e to the power of -4 times 2 and x to the power of 2. So which basically means 9 e to the power of -8 x squared, which will finally be written as 9x squared e to the power of 8. And that's what we're looking at, if that makes sense to you. Let's pick another one. Say let's pick f. So here we're looking at, there's raised to the power of -4. That means you take everything. So first of all, let's get rid of the e to the power of -2 inside the parentheses. So this will be written as 1 over 3e squared, and everything is raised to the power of -4, which will basically be 3e squared because to the positive 4, which will be what? 3 to the power of 4 is 81, and e to the power of, you multiply 8. So this is your final answer. So you pretty much follow. So you can go ahead and do this with everything, and you can look at the key and check if your answers are correct. You can pretty much do the whole thing. So because the value of E is, is 2.718, it's not a bad idea for you to use your calculator to do some of these calculations. So go ahead and use your calculator. Let's take a pause now so that you can bring your calculator, and